odd character. So let me give you a function that algebraically, or that we don't have the picture of. I'm going to change the symbols just so that we get used to not always using F. What letter do you want to use? G? Okay, G sounds good. I'm going to call it capital G because it's a good function. Okay, G of x. How about something like 12x to the 7th power minus 20x cubed plus 3x. Question. Is g of x even? Is g of x odd? Okay. So if it was even, then based on, if you remember what we talked about a few minutes ago, f of x over on the right side, f of x height, would have to equal f of negative x, wouldn't it? Okay, well, we've got our original function given to us. So let's see if what g of negative x is. G of negative x, to test for even character, you put in a negative x here and raise that to the 7th power, subtract 20 and negative x being cubed, and add to it 3 times negative x. And when you raise something that's negative to an odd power, it stays negative, doesn't it? If you take something that's negative and raise it to an odd power, it stays negative.
If you were doing this as a problem, like from the homework, would you even bother writing that out? Or could you just see that if you take a negative x to the 7th power, it's still going to be negative?
After a while, that would be okay in this course. But at this point, I would want you to show me that you knew what you were doing and not just giving me a guess, one or the other, even or odd. Okay, so I'd want you to show me the math. Just like, who was that, Tom Cruise showing me the money or something like that in the movie, right? Okay. So, if you raise something that's negative to an odd power, then that stays negative, doesn't it? So you get negative 12x to the 7th here, and then this stays negative right there, times a negative becomes positive 20x cubed, and the negative times a positive over here is a negative 3x, right? Okay, so that is what you get for g of negative x. And you compare this to the original, right? That's g of negative x. Let me erase that. This thing we just did right here is g of negative x, isn't it? Is that equal to g of x? Look at this and look at the original. No, it's not equal to g of x. So g of x is not even. Okay. And you go, darn, I just did all that algebra. It's not even. Now I got to go back and start over to answer the question to see if it's odd. Okay. If you have that image in your head that we did a few minutes ago, if you're over at some x, it's got a, in this case, a g of x height, doesn't it? Now, if I'm trying to check it for odd character, if I go over to the other side, I'm going to form g of negative x, right? Which, well, we already did that. So that's actually useful information, isn't it? We need that. And now, what I want to do is check and see if, for this odd question right here now, for the odd question, is the opposite of g of x the same as g of negative x? Now, we already did this work. It's sitting right over here. So all we have to do is go back to our original function and take the negative or opposite of it, and you can see that it is the opposite of this 12x to the 7th minus 20x cubed plus 3x. That's this. That's the negative of the original g of x. And observe that, yes, it is the same as this, minus 12x to the 7th plus 20x cubed minus 3x. Notice that they are the same. If you distribute this negative into this, it's the same as that. Okay? So we want you to be able to do these, answer these kind of a question, whether a function's even or odd, either by having a picture in front of you or by just having an equation that describes the function. Okay. Then, if you would turn your calculator on and draw this thing, you would set a window, symmetric window to the left and the right, and you better see the character of the graph where it mirrors itself through the origin. Okay. If you want to take a moment to do that, feel free. And you will, guaranteed, see that it exhibits origin symmetry. Doesn't mean the graph has to touch the origin. The graph does not have to touch the origin. It just has to exhibit that character that it has this symmetry through the origin. All right. Let's look at some of the other stuff. As a matter of fact, this odd function might be a good one to then address those other items. Anybody have a decent picture of it? Okay. I'm going to go ahead and key it in on the calculator, and we'll put it up here on the screen. Just take a moment to do that, and I think we can fairly quickly use it as our example today. And at the same time, I will illustrate use of the calculator on this problem for those who might be watching the DVD. So all I'm going to have available, though, is what's on the screen, so just try to understand the vocabulary I use. So first of all, we go to the y equals screen, and we input our function. There's a technique for using your calculator, and I'll just verbalize it today, and we've talked about it in class before. First of all, you enter the function. So we come in here, and we take this function, 12, and you use your dedicated x key, which is up near the alpha key, and we're going to raise that using the exponent key to the 7th power. We're going to subtract from it using the subtraction key, 20 times x raised to the 3rd power, and then we're going to add to it 3 times x. So we first of all enter the function. What's the next thing we do? We set a viewing window, just like pointing a camera. So we set a viewing window. So we go to our window key, which is one of the top keys on your calculator right below the screen. You go to the window key, and at this point, you're going to make kind of a guess, an educated guess about what to set for the left side, x minimum, and the right side and the tick marks on your x-axis, and similarly on y. So why don't I go -5. Anybody come up with a good window already? Oh, -2, 2. Does that seem to show the character? Yeah. Okay, -2, 2, 1 on our scale marks. Vertically, you probably got to go.
-6, 6.
Okay, let's try -8 to 8, and notice something. The spread here from the bottom of the screen, y minimum, down on the bottom, that's what your bottom of the picture will look like, -8, to the top of the screen at 8, is going to be a spread here of 16, isn't it? I don't want to use a 1 for my tick marks because there'd be 16 little tick marks and it's hard to count those. So I'm going to use something like maybe, how about 2? Because 2 goes into 16, the spread there, kind of nicely. So I'm going to use, say, a 2 for my scale marks. And now this is the first guess. And I said this before in class, the best way to take notes on this stuff when an instructor is doing a demonstration is you write down the equation that's being graphed, you write down these 6 numbers, and then next to it you draw a box on your paper that indicates this. Okay, so we try this. Whoa, look at that thing. This is a great example to use, okay? Now, this exhibits all of the character of this 7th degree polynomial. What I mean by that is it shows the zeros. It shows the zeros. It shows the maximums. These are maximum points. It shows the minimum points. And what is this over here where it's diving down left and over to the right, taking off up to the right? What does that, what do we call that? This is for when x becomes large. This thing's exhibiting end behavior. We call that end behavior because as you move out in the domain to large values, this thing goes upright and off to the left. For large x to the left, it goes down left. So it's exhibiting all the characteristics that we are looking for in these graphs, in these kind of functions. Also notice that we have a scale that you suggested that is higher than where this peaks out, and similarly lower than where this bottoms out. And the reason is if I turn trace on or do some other kind of calculation, the writing at the top and the bottom don't clobber part of the picture. You can see that if I set the top maybe here at 4 or even 6, that this writing up here would have clobbered that spot. Okay, so always try to set a window that's a little lower and a little higher than the character of the graph. All right, feeling good? Notice I have symmetric, I had chosen symmetric windows, actually you'd suggested this, to the left and right. And so when you turn trace on the graph, the trace key is going to set the calculator at the middle of the screen. And notice that what is really nice about this? It tells us that we have a 0. So we know one of the zeros of this function right off the bat. Very nice. And we could then label that on our sketch. Now, if you're taking notes, you have written down y equals what the function is. You have written down the 6 numbers that show the window settings. And then you've drawn a box and included these axes. And then to finish that sketch, what you do is you just simply put a little tick mark where it goes off the screen, where it hits its zeros, where it peaks out, just where I'm showing you right now. Just what you do is put little marks there. Here's a 0, here's a minimum, here's a 0. You just put little tick marks where you see it do this stuff on your sketch and where it goes off the screen here. And then you just connect those with a curve. Okay? Now, what were we talking about before I started doing all this? What were we talking about on the board? Odd character, right? So if I picked a point, let's say I went over here to -1. This is checking a point. It's not checking the whole function. If I go trace -1, you can see the y reading there is 5. If I'm over at -1, you can see the cursor up here at 5. And the point's shown, the coordinates are at the bottom of the screen. How could we check this point now? Go over to +1. Change this to +1. I just hit 1, enter, and you see -5. And all other points will exhibit that pattern. You can see it from the picture. Okay? let's do a minimum. Let's do a minimum. I'm going to pick, I'm only going to have time today to do one of them. Let's do this one right here. Now some of you already know how to do this, but in the interest of having this on the DVD for recording, I'm going to go ahead and illustrate this for those watching the DVD. So what we want to do is we want to have the calculator come in and home in on this minimum. The way we do that is on the trace key of the TI calculator. If you use the second or shift key, you're going to go to a calculate menu. So we go to calculate. The menu looks like this. We have a variety of choices we can make, and what we're looking for is minimum. So what we do, instead of arrowing down with the blue arrows, what we do is simply look at the number over on the left associated with that menu item, and we're going to pick item 3. So if I hit item 3, watch what happens. It brings us back to the screen. And I'm going to leave the pen there to illustrate where the point we're looking for. However, notice the question that's being asked here. It says, what's the left bound? What they want is they want us to come up with a spot that is to the left side of that interesting point, the point we're trying to investigate. So what we want to do is get a value that's a little bit to the left, and then it's going to ask us for a right bound, and we're going to pick a number a little bit to the right. Not too far, though. Okay, so we're going to do left bound first. What would you guess? -0.5. Okay, -0.5 would be about where the pencil point is. Okay, so I'm going to pick -0.5. And what it does is it leaves a little arrow up here pointing to the right. That's the left edge of our interval. And then we're going to pick another spot. Why don't I pick, say, 0? In the interest of time, I'm going to go a little bit faster. So now notice it's given us an interval, and the third question it's asking is, what's a guess? So I'm going to pick something in between there. Why don't I pick maybe -0.2? And I just punch that in using the negative key and hit enter, and the calculator cycles, does some testing of points, and it comes up with this result. So there's your answer, -0.2240. And what I would do on my sketch is I would come in with my pencil right here, and I'd use my parentheses key, or parentheses, and I'd write down -0.224, comma, and then here's the y value right here. This is the minimum value. Okay, now listen to what I'm saying. This is the minimum value of g of x at this location. Okay, this is the location, this is the value. Okay, that's the way that you find minimums, like here, and maximums here and up here. Okay, now let's go ahead and hang on to that point. Somebody make sure you write that down, because I'm going to go back up on the board here in a minute after we're done with the calculator, and in closing I want to show you something. So what I want to now do, I don't have time to do every portion of this graph, but what I now want to do is go ahead and quickly find the maximum right here. If you're watching the DVD, you can pause it, use your calculator, get it, and then turn the DVD back on and see if you come up with the same result we do. So I'm going to go for this maximum now, real quickly. So here we go. Calculate. Maximum this time, item 4. I go to the left bound. I'm going to say maybe -1.5 by looking at the scale marks. I'm going to pick a right bound at maybe -0.5. Notice the region, the interval that's set up here, and then I'm going to pick a guess maybe at -1, which is inside that region, and I hit enter. And some of you in class, please write this down. At 0.9050, rounding off to 4 decimal places, down here, 4 decimal places, we have a reading of 6.143 approximately. Okay, let's go back up on the board for the last couple minutes. we have a sketch of this thing. And I'm just going to do it quick in the interest of time. And then if I know it's odd, folks, right? If I know it's odd and I've got this drawn, then can't I just mirror that, what I'm seeing there? Whoops.
It's probably easier just to draw.
Yeah, I think it'd be better just to look at the screen, right? So this thing takes the die, comes down here, and then does that, right? Okay, and what we pinned down was this point. This is our minimum at what? Negative 0.224, comma?
4476.
Negative what?
Negative 0.448.
Okay, good enough. And this maximum? This is a min.
Negative 0.9050.
I'm sorry, say it again.
Negative 0.9050.
Comma?
Comma.
6.1.
6.143.
Thank you. Okay, and so the reason I wanted to get those down is because notice there is something on the properties that I hadn't mentioned yet today other than at the beginning about regions of decreasing and increasing. And you can see right here, you can actually on your sketch, you can label that it's coming from this maximum dropping to the minimum, and there's a region of decreasing. Notice there's another region of decreasing over here. And do you need your calculator, folks, to do these others over here? No, because you know the symmetry of the function. Do you see how handy that symmetry is? You don't need to go use that calculator to find this little peak and that valley because those are mirrored points of these. Okay, so what we could then do is if we're looking for decreasing intervals on this graph, all we'd have to do is say that they are from the open interval, 0.9050, over to negative 0.224, and then where else? Here to here, right?
224.
Between here, and between here and here. Isn't that true? Those are regions of decreasing. And what about regions of increasing? Doesn't it start off to the left here, from negative infinity on the left? Coming over to this 0.9050, and then another increasing interval,
From negative 0.224
right?
to positive 0.224.
From negative 0.224 to positive 0.224. Any other increasing intervals? Yeah, thank you. Okay, and we're almost done. From 0.9050 out to infinity. So here's your interval notation for answering the question, decreasing and increasing. So I think, other than talking about average rate of change and instantaneous rate of change, I think we're in pretty good shape on this. Feel good? Question?
On the homework, after like it would say the equation, it would give like a set of parameters, like it would say negative 2,
Yes.
2 or
Thank you. What it asks in homework is it gives you an interval in which to do your investigating. So use that and your calculator, okay, and then investigate in that region. They're helping you out a little bit, whereas up here on this problem, I just said let's look at the whole darn thing.
So if it says negative 2, 2, that would be negative 2x.
Negative 2 over to positive 2.
Okay.
Yes. And I think we got to cut off the DVD. I'll take more questions in just a second. So that's it for today. What was your question? Usually it's your 4.